Activity 1. Expanding and simplifying polynomial expressions. This activity is part of Unit 4, Applications of Quadratic Relations. Remember grade 9 algebra basics. Polynomials are algebraic expressions that involve one term or the sum of two or more terms. Since this definition is so broad, there are more specific names for the various types of polynomials, depending on the number of terms they have. So here are some examples. Notice each one has a different number of terms. We can categorize these polynomials by the number of terms they have. So a monomial has one term. Both of these examples only have one term. Binomials have two terms. And trinomials have three terms. Here are some more examples. Monomials with one term, binomials with two, and trinomials with three terms. We're going to look at some of the algebra tiles that we're going to be using in this lesson. These algebra tiles you'll see throughout. Notice that the positive algebra tiles are represented by red, whereas the blue ones represent negative values. So negative y is in blue, positive y is in red. Notice that 1 is a perfect square, and negative 1 is also a perfect square. Then we have our x's, our y's, and our z's. And then we have our x squares, y squares, and z squares. We also have x and y, and x and z. So, let's look at multiplication. Multiplication by expanding. 5 times 47 is equal to 235. You can write this as 5 times 47, which is equal to 5 times 40 plus 7. The expression 5 times 40 plus 7 is considered a product referring to the multiplication by a monomial 5 and a binomial 40 plus 7. Here's the monomial, here's the binomial. So, to complete this, you multiply 5 times 40 and add 5 times 7. The conversion of the expression 5 times 40 plus 7 to 5 times 40 plus 5 times 7 is referred to as expanding the expression, and it employs the distributive property. So the 5 multiplies both terms of the binomial. This is the distributive property. When we carry out these multiplications, we get 200 plus 35. The next two lines where you get 200 plus 35 and finally 235 are simple arithmetic and are called simplification steps. We're simplifying our answer. Here's a model for multiplication. Multiplying a width and a length together produces the area of a rectangle. So if we look at this rectangle, we find out the area by multiplying length times width. You can use this fact to model the multiplication of any two numbers, including unknown widths and lengths, that can be represented with variables or expressions. So for example, the length might be x plus 2, and the width might be x. We can multiply those two together. Now recall that 1 is represented by a red square, and that the area of this red square is 1 times 1, which is 1 unit squared. Here's an x. This rectangle that represents x is 1 times an unknown x length. So it's 1 times x, which equals x units squared. This larger one is an area that is represented by x times x, which is equal to x squared units squared. For every quantity, there is an opposite. And so if x squared represents an area of a wall that has been painted, the expression negative x squared could represent an area of the wall that needs painting. So here's the corresponding negative units. To allow us to use more than one variable term, let's introduce the other length tiles. We have y's, where the area is equal to 1 times y, which equals y units squared. We have y squared, which is y times y, which equals y squared units squared. We have negative y and negative y squared. We also have z. The area is equal to 1 times z, our width being 1, and our z is our unknown length, which produces z units squared. The area for this one, z squared, is z times z, which equals z squared units squared. And here are the corresponding negative values, or negative areas. What will the following areas look like? The width is x units, while the length is y units. Well, it would look like this, xy. How about if the width is x units, but the length is z units? This area would be xz. And if the width was y units, and the length was z units, it creates yz. Simplifying expressions with tiles. Here's an expression. 1 plus 1 plus 1 plus 1. Here it is represented in tiles. The simplified expression is 4. Let's look at another one. The expression y, negative z, y, negative 1, negative 1, negative 1, and y. This is what it would look like. Y minus z plus y minus 1 minus 1 minus 1 plus y. We can simplify the expression. We organize like terms, and we get 3y, seen here, minus z minus 3. There's our simplified expression. The grouping of the y tiles and the 1 unit tiles in this way is called collecting like terms. We collected the y's together, the negative units together, and the negative z. Take this moment to simplify this expression.